Hi, I'm Erica Kleinman. I'm a PhD student at UC Santa Cruz studying under Dr. Magy, Seif, El-Nasr, and today I'm going to present a paper we worked on in collaboration with a few other authors titled, What Happened Here? Towards a Taxonomy for User Interaction with Spatio-Temporal Game Data Visualization. So diving right into it, what is a taxonomy? Well, in InfoVis, interaction taxonomies are formalizations of the actions users take when trying to make sense of visualized data. So they include things like gaining an overview, examining details on demand, relating data points, and these are used in InfoVis to make informed decisions about how to design data visualization tools. But you see, while there are many taxonomies for InfoVis at large, there currently aren't any that apply specifically to visualized game data. And that's despite the fact that game data visualization has become really popular lately in industry and academia, and even for players themselves. And you see, that's a problem, because players are often using these visualizations to learn and reflect on gameplay. Not only their own, but others' gameplay too. But you see, we don't have any formal idea of how they're making meaning from the data, which means that we don't have any informed guidelines on how to design to support that. And unfortunately, existing taxonomies are not easily applicable to games due to the very different contexts from which the data comes, and because existing taxonomies often do not include the cognitive elements, which are very important to using data to learn from gameplay. So we set out to develop a taxonomy for game data by answering the research question, what are the interactive activities and cognitive processes that players engage in when they're analyzing spatio-temporal gameplay data? And we specifically chose spatio-temporal data because it's granular and context-rich, which we find is very beneficial to players who are looking to learn from the data. So we conducted a Think-Aloud study with 7 DotA 2 players who had between 3 and 8 years of experience. And all were asked to use a tool called StratMapper to interact with telemetry data from unfamiliar DotA 2 games, meaning games that they're not a part of. We specifically chose unfamiliar games to better replicate the context of data being used to learn from others' gameplay, and also to ensure that we'd see the participants trying to extract meaning from the data rather than just recounting what happened from their memory. And I don't have time to go into all the steps of the Think-Aloud protocol here, but it is all in the paper. Essentially, the participants were prompted to identify strategic gameplay maneuvers within the visualized data and vocalize their actions and thoughts as they did so. And of course, because of COVID-19, these sessions were carried out remotely over Google Meet, and screen and audio were recorded. And just really quickly, this is StratMapper, so this is the tool that the participants interacted with. So based on content analysis of the videos performed by 2 researchers who reached an iterator reliability of 0.82, we identified 7 actions that players took while making sense of the data, and these are sorted into 3 categories, which I'll now go into in more detail. Data interaction relates to how users use the tool to read the data, and it includes studying positioning to construct context, in which we see the users examine the location of players on the map to try and gain a mental model of the gameplay context, studying movement to infer decisions, in which a user used the tool to examine how players moved over time to infer their decisions, and seeking details to support sense-making, which refer to the process in which a user would intentionally seek out more information regarding the state of the game to support the process of making sense of the data. Speaking of which, sense-making relates to the cognitive activities that users would engage in while interacting with the data in order to extract meaning and develop an understanding of gameplay. This includes leveraging domain knowledge to fill gaps, which refers to the process by which participants would fill in gaps in information based on their knowledge of the game at large. Pinpointing events to frame understanding, by which participants would identify a single event and use it to frame their understanding of a moment of gameplay. And forming a hypothesis of context and behavior that evolves over time, which was the process by which participants would provide theories for what was happening within the game. And the last category, validation, contains only review events to confirm hypotheses, which is the process by which participants were observed to validate their understanding of events at the conclusion of an analysis. In addition to the taxonomy, we also present a preliminary process model for how users make meaning from spatio-temporal game data. Participants will engage in the data interaction activities interchangeably with the sense-making activities in order to build an understanding of gameplay context and player behavior. That is then used to form a hypothesis, which may evolve over time and may trigger additional executions of the other activities. If the user believes that they have enough hypotheses to satisfactorily explain and understand all the data, they will proceed to validation and review the events to confirm their hypotheses. If they find a discrepancy, they will then return to the process of building an understanding in order to form a more accurate hypothesis. And this entire process is part of a larger process of specifically constructing a mental model of gameplay. And based on these findings, we present some implications for future design and research, which we again discuss in more detail in the paper. But broadly, we suggest that future systems should consider including interactive features, consider variable arrangements of details, be cautious of over-abstraction, explore potential AI support for identifying key moments, and ensure that users can see data in both granular and holistic manners. So in summary, we conducted a Think-Aloud study with 7 DotA 2 players in order to develop an initial taxonomy for user interaction with spatio-temporal game data. Future work will look into expanding the taxonomy to account for other visualization types, games, and use cases. Thank you.